This is AP Calculus Self-Check 8.5 Solutions. So we have a rock concert, and our equation is a rate of people entering the concert, enter the auditorium, and at 2 hours then no one is permitted. Or yeah, they'll start, I guess. No one is in the auditorium, so our initial condition is 0. And the doors close at time equals 2. Okay, so how many people are in the auditorium when the concert begins? So when the concert begins, we know that we're doing start plus change equals end, essentially. So our start is, well, we start with 0, and we're going to add the number of people that change. So we're looking for people. We're not looking for a rate. We're given a rate. It says that the rate at which people enter an auditorium. So to get from rate back to people, we need to be finding the integral. So this is going to be the integral between 0 and time equals 2. That's when it starts. Of this function, this is the rate entering the auditorium. So this is going to be capital R t dt. And now we need to find that in our calculator. So let me open up our calculator file, open recent TI-83. Cool. All right, so I'm going to go to my y equals. I'm going to enter this 1380 t to the power of 2. Okay, just do it like this. And that's going to be subtracting 675 t to the power of 3. All right, so we have the function, and that's going to be between, we don't need to graph this, but if I want to set my window, just in case I do need to graph it, 0 to 2. So now I need to do this integral. So it's going to be 0 plus this, so I really am just doing math 9 integral of my y1 variable, and that's from, or with respect to x, from 0 to 2. Oh, 0 comma 2. There we go. And 980. So this thing is not approximately equal, it's exactly equal to 980 people. All right, so on to part B. So find the time the time when the rate of people entered the auditorium is at a maximum. Justify your answer. So I'm looking for a rate in this one. I'm not looking for any integral. I'm just looking at our normal function. So when is that rate the highest? Well, the easiest thing is to look at the graph, right? So if I now do zoom 0, I have my window set between 0 and 2 already. So this function models the rate, and you can see that the rate is at a maximum at that point. But in order to get credit on the AP exam, you do need to show a little bit of work. So on the AP exam, you need to find all critical values. So the critical values, again, the definition of that is when you take the derivative and set it equal to 0 and find everything that happens. So I'm taking this function and I'm taking the derivative, r prime of t, and I'm setting it equal to 0. So there is a way to do that on the calculator, and there is a way to do it by hand. I think doing it by hand is probably a little bit faster. So r prime of t, we're going to set that equal to 0. So if I take the derivative, if I multiply down by 2, that's going to be 2,760 t, and then 675 times 3. I'm going to mess that up, so I'm going to just use my calculator. 675 times 3, 2,025. So t minus 2,025 t squared, and I need to set that equal to 0. I can factor out a 15t from both sides, so this actually turns into, I'll go over here, so this turns into, what is it going to be, 15t being factored out. If you don't know what number you can factor out, I can show you a cool little trick too. Math, right? You're finding the GCD, the greatest common denominator. Greatest common, that's right, greatest common denominator. I think that's right, yeah. GCD of 2760, comma 2025. What can I factor out of both of those? You can factor out a 15. So if I factor out a 15, divide both of those by 15, I'm left with 184 minus 135 t, and that's set equal to 0. So obviously if I set 15t equal to 0, I get t is equal to 0, and if I set this thing equal to 0, add the 135 over, and I'm left with the fraction 184 over 135. So maybe you don't like calculating it by hand. Maybe you like doing the calculator. How would you do that? There's two ways to do it. Here's the easiest way, and Joy has done this way at the very beginning. If you go to the graph of your function, you'll say, oh, it's just right there. How do I find that t value? I know exactly what it is. It's 184 over 135, but the easiest way is to go second, calculate. We're trying to find the maximum, so I hit 4. And left boundary, sure, enter. Right boundary, I can just hit enter 2. And my guess, I don't know, somewhere in between 1.5. And we'll tell you, oh yeah, your t is 1.363. And that is what that approximates to. So I can say, using your calculator, you can get the same values. I'll write 1.363 up above this fraction. That's probably the quickest way and the way that I prefer on the AP exam, because it's just, look how much time we save by just doing that. So those are the two times that we want to look at. Again, this value came from looking at the critical value by setting the derivative equal to 0. Now I need to find which one of those is the maximum, and you do have to make a table here because you have to show, okay, obviously it's not 0. The reason being, if I do t and rt, if I plug in my endpoints 0 or 2, I'll find a number, and if I plug in 1.363, I'll find my maximum. At 1.363, it's already telling me my y is 854.827, so 854.527. At 0, if I go to trace and I hit 0, my rate is 0, so that's definitely not a maximum. And it doesn't look like my maximum is at 2 either. If I hit 2, my rate is, oh, exactly 120. And our answer is here. Look at that. That's the biggest rate. So again, the question is asking for where is the rate at the maximum. So find the time. We're really looking for the time. So max at time is equal to this thing, 1.363. And on the AP exam, they actually do prefer a decimal over the fraction, although Mr. Sindel does prefer the fraction because it is exact and this is only an approximation. So I guess if we were being really precise with our language, we would have said this is not exactly equal, it's approximately equal to 1.363, and our units are in hours. On to part C. Total wait time. So basically it's saying that total wait time, the derivative of wt is this function here. And it's looking for the total wait time between 1 and 2 hours. So this thing, if you want to interpret it, this is the total wait time between 1 and 2 hours. But it only gives us the rate of the wait time. It doesn't give us the total wait time equation. It would be nice if it gave us w of t is equal to this, then you just plug in 2 and 1 on your calculator and then subtract them, but it doesn't give us this. So how are we going to be able to find a w function without using the prime? How do I get from the prime to the w? And you might be thinking, fundamental theorem of calculus. If you take the integral of the prime, you get back to the normal w, and that is exactly the case. So if I undo the prime by taking the integral of w prime of t, then I'll get back to my w. But notice that this is going to be w2 minus w1. So our bounds for our integral, we can actually just say between 1 and 2, and what that does essentially is it says, okay, well, when I evaluate, it's going to be w2 minus w1. So what I'm really looking for, although it says I'm looking for w2 minus w1, what I'm really looking for is this integral from the bounds 1 to 2 of the w prime function that they gave us. So what do? We need to plug this function in on our calculator and then do math 9 to take the definite integral. So on our calculators, we're going to go to y equals, we're going to come down here, and we're going to say, we're going to do in parentheses 2 minus t, in parentheses 2 minus t. And then we're going to multiply that by our t, our y1 function. So I just need to enter y1 here. Vars right, enter, enter. And now I have w prime t. This y2 represents w prime of t. So if I get out of here, and now I need to take the integral. So I do math 9 of that, vars right, enter 2. this with respect to x from 1 to 2, and I will get the total wait time. The total wait time between 1 and 2 hours was 387.5. So this is exactly equal to 387.5 hours. And I forget, or I have been forgetting to tell you how to score all these. I should start doing that now before I forget. So let's go back here to the first part. In the first part, you get 1 point if you have the integral. You don't need the initial condition, and you get 1 point if you have the number of people with correct units, people. For part B, so this one I should say out of 2 points. For part B, there are 3 points to get. So you need to set the derivative equal to 0. So by me setting the derivative equal to 0, I gave myself 1 point. If you find the critical point, so if you found this number, 854, then you give yourself plus 1 point. And if you have your conclusion, which is the max is at time 1.363, you give yourself 1 point. So the conclusion is 1 point, finding the critical point, the y value is 1 point, and setting the derivative equal to 0. All right, part C, 2 points. I forgot to do this, out of 3. And then this one is going to be out of 2 points for C. The 2 points come from getting this integral correctly, knowing that you were supposed to use the integral, and finally getting your answer with correct units. And then part D, this is going to be out of 2. How do I do part D? So now we're looking for an average. How long does the person wait in the auditorium? Well, look, in part C, we had to find an equation, find a method to calculate wait time. Total wait time was between 1 and 2 hours. What it's really asking for now is total wait time between 0 and 2 hours, because the concert will begin between 0 and 2 hours. It begins at 2. So what I'm really doing is I'm finding the integral between 0 and 2 now of the same thing, w prime of t dt. And then I need to find an average. Well, how many people were there? Because this is going to be the total wait time. If we do total wait time divided by total people, that will be the average wait time per person. Well, how many people entered between 0 and 2? That sounds familiar. That's part A. There were 980 people. So I can just write this is going to be divided by 980 people from part A. All right, now I need to do this on my calculator. This is going to be, it might be approximately equal to, I shouldn't write equal to yet. I need this function again. I do second enter to go back to the previous line, and instead of entering 1 and 2, I do 0 and 2. What number does it spit out? 760. It is a nice number, a nice integer. This is 760 people over, or 760 hours, and there are 980 people in line. So this is hours and people. And when I reduce that fraction, it is looking for decimal. It's going to be 760 divided by 980. This is going to be the average wait time per person, 7.776. We'll go to 3 decimal places. So this is approximately equal to 0.776 hours per person. How to score yourself. So in terms of points, this is going to be 1 point if you have this integral between 0 and 2. You don't have to divide by 980 to get your plus 1 here. So plus 1 if you have that integral correct, and plus 1 if you got the answer of 0.776. I don't know if they'll give you points for the fraction. You do always need a decimal. So plus 1 here. All right, perfect. So score yourself on this one. This was out of 1, 2, 3, 4, 5, 6, 7, 8, 9. This was out of 9 points for that first part. All right, we're moving on to the next problem. So we have a traffic flow problem. Again, we are using calculator because number 1. So to the nearest whole number, how many cars pass through the intersection over a 30-minute period? So if it's how many cars, not how many cars per something, it's not a rate. We need to go from a rate, this is a rate, to just number of cars. So you should be doing the integral. Integral between, so over the 30-minute period, between 0 and 30 of your function, f of t dt. All right, so when I do that, let's see what number we get. So again, I need to plug this in. So let's get rid of these, get rid of those. And my function is 82 plus 4 sine of x divided by 2, all that, and my window is going to be between 0 and 30, just in case I ever need it. 0, enter, 30, and second quit. Okay, so I have my equation, and I'm doing the integral. So math, 9, and integral of my y1, so var is right, enter 1, and that's going to be comma with respect to x, comma between 0 to 30. All right, so when I do the integral, I get about, oh yeah, and I'm going to round to the nearest car here, so it's going to be 2,474 cars. All right, how to score yourself? You get 1 point if you have the limits correct, so +1 if you got 30 and 0. You get 1 point if you have the integrand, everything else, so +1 if you got the rest of that, and +1 if you have the answer with the correct unit. And yeah, you do have to have, you can't do point something cars. You have to have a full number here, a whole number, an integer. Part B. I should write this out of 3. Out of 3. And you should do the same thing on the side so it's easier for me to count them up. All right, so B, is the traffic flow increasing or decreasing? Okay, so this is talking about the flow. So this is talking about capital F of t. It's asking, is this function here increasing or decreasing? So if it's ever asking about anything increasing or decreasing, you need to go a level deeper. You need to take the derivative of whatever it's asking about. It's asking about flow, it's asking about the rate, and it's asking about if the rate is increasing or decreasing, so we need to take the derivative, f prime. So we're looking for the slope of the graph, essentially. So if I go to zoom 0 and graph this, I just need to know if that slope is positive or negative at t equals 7. So it's going to be hard to see where t equals 7 is. So after I hit, after it's graphed, I'm going to hit trace. I'm going to go to 7, I hit enter, and at 7, you can see right here that the slope is definitely a negative. So we'll say that f prime of 7, the slope at 7, the derivative of this thing is going to be less than 0. So let's do our answer now. So our answer is traffic flow is decreasing, and here's your reason: because this thing, because capital F prime of 7 is less than 0. All right, if you have all of this reason, that's +1. You need everything here. You need, it's decreasing, and because of this thing. So that's out of 1 point. All right, on to part C. What is the average value of the traffic flow? Okay, so traffic flow, this is the rate. So this is a rate. And it's asking for the average rate over this time. So do I need an integral? Do I need a derivative? No, I'm just talking about rate here. So in order to find that rate, I need to, oh wait, sorry. If I'm looking for average rate, this is related to unit 7. Average rate is going to be, I'll write this down too, average rate.
Isn't the F A and
Close. This one is going to be, it's the total displacement all over total time. Yeah, so you just need to know this is the definition of average rate. So I don't have the total displacement yet, so that's going to be, displacement again is just integral between whatever time interval 10 and 15 of my function. My function was capital F of t. Capital F of t dt, and that's going to be all divided by total time between 10 and 15, so 15 minus 10. This is going to equal, okay, I'm going to do the integral on my calculator, so get out of here. I'm going to do, oh, I already have the integral, so second enter, and between, instead of 0, it's going to be between 10, comma 15. And I have 409, so let's go ahead and do that. So it's going to be 409.496, all divided by 5. So I'll come over here and I'll say answer divided by 5, and I get 81.899. So this is, I guess I should have done approximately equal to there at this point, because I was approximating the numerator. So that's going to be 81.899. Don't forget our units, because it does say indicate units of measure for this one, and that's going to be, it's a rate. So what was the rate from the problem? It's going to be cars per minute. So this is cars per minute, MIN. And I'm going to fix this just so that it looks better. I want this to be approximately. Oh, come on. Grab this. Delete. I don't know. Oh, that's why. Haha. I have to switch to this program. If the calculator is up, it thinks I'm on the calculator. And perfect. So that's our answer. How to score this thing. This thing is worth just 1 point. So if you got the answer correct, which is 1 point. Wait, where am I on part C? Sorry, this is out of 3 points. I was looking ahead. This is out of 3 points, and so if you have the limits, so if you have these things correct, that's plus 1 point. And if you have the rest of the integrand, so if you have this thing, you knew that you're taking the integral of this thing, that's plus 1, and your answer with units is plus 1. And then D is the one that's out of 1 point. And you might notice that this is adding up to 8 so far. What is the average rate of change of the traffic flow over the time interval from this to this? So now I'm looking for average rate of change of the traffic flow. So this is different. I should not use red also. So the distinction between C and D is very slight. So this is the average rate and then the average value. So these keywords here, I totally messed it up in this part too. I should have said average value. Sorry about that. So this should be average rate now. Average rate. I need to find all of the rates and then divide that by total time. I need to find all the values and divide it by total time for this one. So to find all of the rates, instead of doing the integral now, I'm just doing all the rates just without the integral. And I'm going to say it's going to be, I plug in 15 into my function, I plug in 10 into my function, and I do 15 minus 10. So this is the average rate. So average rate is very similar to average slope. I think, is that from unit 3? This goes all the way back to maybe unit 2 or unit 3. I forget where this happened, where we're finding the average slope. Average rate is kind of the same thing as average slope, and it's an equation that we memorized forever ago. Average value is different. That is from unit 7. So when I do this function, what am I going to get? I have to plug this in to my calculator here. So when I have my calculator, I'm going to do vars right, enter, enter. y1 of 15 minus vars right, enter, enter. Y1 of 10, and so the numerator is going to be that, and I'm going to divide it by 5. So I get 1.518. So this is approximately equal to 1.518, and that is going to be indicate units of measure. So that's going to be wait a sec. This is going to be cars per minute squared, I believe, for this one. Wait, hold on. Let me think about this. The average rate of change. This is definitely cars per minute squared, and this one should be cars per minute. Yeah, okay. We got those rates correct. So how do you score this one? This is just 1 for the answer, plus 1. So where does that 9th point come from? Because right now we have 1, 2, 3, 4, 5, 6, 7, 8. If every single one of your units are correct, every single one, cars here, cars per minute squared, then you give yourself plus 1. So plus 1 for all units. If you missed one of them, you don't get this point. And this is very common on the AP test, where every single unit has to be correct for the entire problem. There's lots of those. And finally, on to self-check 8. This is 8.7 now. I should change this. 8.7, and this one should also be 8.7. Actually, all of them should be 8.7, then 8.8. I think, did I mess up on this as well? Oh well, I can go back and fix that. So 8.5 and 8. Oh, so those are 8.5. This was still 8.5. So this one should have been 8.5. Got it. That was the mistake. And then this one should be 8.6. There we go. All right, so oil's leaking from a pipeline, and the volume is increasing at a constant rate. So this is actually a related rate problem. So the volume is increasing at a constant rate, so V prime is equal to 2,000. That's what this is saying. The oil slick takes the form of a right circular cylinder, so our shape here is a cylinder, and it tells us that the volume of the cylinder is that. Okay, perfect. So at the instant when the radius of the oil slick is 100 centimeters, so that tells us that the radius is equal to 100, and the height, h, is equal to 0.5. The radius is increasing, so radius r prime is increasing at 2.5. At this instant, what is the rate of change of the height? So we're looking for h prime is equal to what? So h prime is our box, and with respect, okay, so we definitely need a v prime. I know that for a fact because v prime will give us an h prime. So v prime is equal to, so differentiate with respect to both of these variables. So it's going to be 2 pi r prime. So that's d1 times 2. Remember, this is product rule because there's two variables here. And then that's going to be plus 1 d2. So sorry, we're doing this a little bit backwards. Maybe I should just do this forward. Sorry. So 1 d2 would be pi r squared h prime. So that's 1 d2 plus 2 d1. H times pi r, bring down the 2 r prime. So there's v prime, and we also will probably need v as well. So let's plug in everything that we know for v prime. V prime is 2,000, so 2,000 is equal to pi. We know radius is 100, so 100 squared h prime. We don't know h prime. There's the unknown. That's going to be plus 2. We know h is 0.5. We know radius is 100, and we know r prime is 2.5. So we know everything in here but h prime, so just move everything to the other side. So let's multiply all these together first. And you shouldn't need a calculator for this, but I'm going to do it just so I can speed this up because we're almost out of here. So this is going to be, it would be, actually you don't need a calculator. It should be 2.5 times 100, which is 250, right? Because 0.5 times 2 is 1, 1 times 100 is 100, 100 times 2.5, move the decimal place to the right, is 250. So this whole thing is 250. So if I subtract 250 from both sides, I'm left with 1,750 is equal to, we'll do 1 with 4 zeros, so 10,000 pi h prime. Divide both sides by 10,000 pi, and you're left with 1750 all over 1 with 4 zeros pi. That is equal to our h prime. And let's see how to square this thing. It turned into a decimal. I guess you're supposed to be using calculator. Let's calculate what that decimal should be because I don't know if it's correct or not. 1750 divided by 1, 1, 2, 3, 4, and then I'm going to divide that by pi. I get 0.055. Uh-oh. That doesn't look like it's the right rate. We did something wrong. Oh no. Okay, we need to find our error. This is not good.
Wait, you said...
Their decimal that they got was 0.038, 0.039. So 0.039 was the answer that they got. What was our mistake? We did 2. Oh my god, I see what we did. There's our error. We didn't, yeah, so dang it. So there should have been a pi in here. So we should have subtracted, this is gross. This is going to be...
But then it'll just be 1,750 divided by 10,000, right?
So
isn't that easier?
We have to subtract, so this number right here. So this number here, delete this, delete, come on. Technology, you're failing me. It's really hard to grab these numbers, and I can't erase them because it takes too long. So this should be 2,000 minus 250 pi, like that. Now, if we run that number on our calculator, let's try this. It's going to be 2,000 minus 250 pi. There's that number, and then I'm going to divide that by 1, 2, 3, 4, 4 zeros times pi. That's going to be, we got the right number. So now, the right answer, let's get rid of that. Actually, I think I can select this. Don't select that part. There we go. So therefore, our h prime is approximately equal to, on our calculator, we got 0.039. And yeah, I think you said centimeters per minute. All right, on to, or do we have to get out of here?
Yeah, we're like
All right.
3 minutes over.
Darn it. And on to part B, that is going to be 3 points. So oil is being removed at this rate, so this is going to be the negative rate. Oil is still leaking at 2,000 rate, or 2,000 cubic centimeters per minute, so that's our positive rate. This 2,000, and we need to find when the maximum volume is, the time when it's at the maximum volume. All right, so they're essentially giving us our V function. So our volume, our V, the V prime, how much the volume is changing with respect to time. Our volume function is now 2,000 minus this RT. I could have written 400 squared root of T. So I need to find where the oil slick is at its maximum, so I need to find the critical values of my volume function. So I need to say V prime equals 0, set this thing equal to 0, and solve. So when I set this thing equal to 0 to find the critical value, I'm just going to use my calculator. So to do that, it's already there because I made a mistake last time. I'm going to enter in my equation, minus 400 square root of x, and then for my window, I'm going to go from 0 to 30. I could have gone from 0 to 50 here. I just don't know where it ends. So when I go zoom 0, this is the graph that I get. I'm looking for where this has a 0 value. Looks like it's right about there. So to find that, I'm going to do a second trace, and then I'm looking for 0, so I hit 2. And left boundary, anywhere on the left is good, so like 0 to 30 for the right boundary. Anywhere in between is fine, so 10. And we find that the critical value is at x equals 25. So t equals 25 when I set this equal to 0. That's the critical value. And does it make sense to plug in our initial value at time equals 0? It doesn't, because at time equals 0, we don't know what's happening. We just are looking for our critical value. So is this going to be the maximum? Let's make sure this makes sense. So the height of the graph is our V prime. So the height goes from a positive to a negative down here, which means that this critical value is a maximum. A positive to a negative sign change is a maximum. So our answer here is, find the time, so maximum at time equals 25 minutes. I think we're in minutes here, right? Yes, minutes. And you need the rationale, the justification, and it's because of the, we'll say because I defined this function, because of the V prime of t sign change. And you do need to say it's a maximum because it went from a positive, so from positive to negative. And for part C, so it's saying by the time we began, there are already this amount leaked. So now it gave us an initial condition. So we need to evaluate, or not evaluate, but just write an integral that gives the volume found in part B. All right, so initial condition is basically start plus change equals end. We're not finding a function. We're not doing from 0 to t. We're just giving a solid amount of oil. So it's going to be 60,000 to 3. We're going to do the change between 0 and the time that we found in part B. In part B, we found t equals 25, so 0 to 25. And then we need our V prime function. So our V prime was 2,000 minus RT, so I'm just going to write 2,000 minus RT. All of that thing, dt. I could have wrote V prime t since I formally defined it up here, but I'll just leave it like this. And there's our answer. So let's go back through this thing and score ourselves now. So on part A, there were 4 points. So you need to first have all of your, I think you have to analyze that your V prime is equal to 2000 and your R prime is 2.5. So it's a little bit out of order, but that thing and that thing are both +1. And if you found an expression for V prime, so if you just calculated V prime, which was a little bit hard, that's actually +2. And then plugging in everything and finally getting your answer, that is +1. So that is out of 4 points for number 1, or for part A. For part B, there's 3 points. 1 point if you set RT equal to 0, so if you set this whole thing equal to 0, that's +1 to try to find the critical value. If you found your answer of 25, that's +1. And if you justify by saying V sign change, or this thing changes sign, this function changes sign, that's another +1. You should say from negative to positive too. You need to say that. That's how you know that it's a maximum. And for part C, this is going to be out of 2 points to bring the total to 9. And you need to have the initial condition and the limits. So if you do that, and that's +1 for all 3 of those things. And then if you have the integrand, like everything in here, correct, that's another +1. And we can say that this one was out of 9 points. And for part C, so it's saying by the time we began, there are already this amount leaked. So now it gave us an initial condition. So we need to evaluate, or not evaluate, but just write an integral that gives the volume found in part B. All right, so initial condition is basically start plus change equals end. We're not finding a function. We're not doing from 0 to t. We're just giving a solid amount of oil. So it's going to be 60,000 to 3. We're going to do the change between 0 and the time that we found in part B. In part B, we found t equals 25, so 0 to 25. And then we need our V prime function. So our V prime was 2000 minus RT, so I'm just going to write 2000 minus RT. All of that thing dt. I could have wrote V prime t since I formally defined it up here, but I'll just leave it like this. And there's our answer. So let's go back through this thing and score ourselves now. So on part A, there were 4 points. So you need to first have all of your, I think you have to analyze that your V prime is equal to 2000 and your R prime is 2.5. So it's a little bit out of order, but that thing and that thing are both +1. And if you found an expression for V prime, so if you just calculated V prime, which was a little bit hard, that's actually +2. And then plugging in everything and finally getting your answer, that is +1. So that is out of 4 points for number 1, or for part A. For part B, there's 3 points. 1 point if you set RT equal to 0, so if you set this whole thing equal to 0, that's +1 to try to find the critical value. If you found your answer of 25, that's +1. And if you justify by saying V sign change, or this thing changes sign, this function changes sign, that's another +1. You should say from negative to positive too. You need to say that. That's how you know that it's a maximum. And for part C, this is going to be out of 2 points to bring the total to 9. And you need to have the initial condition and the limits. So if you do that, and that's +1 for all 3 of those things. And then if you have the integrand, like everything in here, correct, that's another +1. And we can say that this one was out of 9 points. And on to the second part. So we have our rainfall inside of a reservoir, and K. K is the rate at which water is being pumped out of the reservoir. So this is our negative rate, and this is the positive rate up here. Positive rate because that's how much water is going into the reservoir. And so we need to find K. So in order to do that, we need to find the total amount of water that's going into the reservoir. And then remember at 9 p.m., the time that this function ends, 12 hours later, there's still exactly 500,000 gallons of water, because it says it's 500,000 at the beginning and at the end. So what we're going to do is we're going to find that K, this negative rate, so maybe I should just say the negative rate here, that's going to be equal to the total water that we accumulated divided by the total time that it took to happen. So the total water, that's going to be the integral between 0 and 12, 0 and 12 of this function. I'm just going to put RT dt. And that's going to be divided by total time is 12 minus 0. All right, calculators, here we go. So I need my oh god, is it doing its thing again? Come on, turn on. There it goes. Okay, so y equals, let's get rid of this. It's going to be 73000. There's 3 zeros. That's going to be divided by, and then in parentheses here, x squared minus 8x plus 25, and parentheses here. All right, so we have our function, and it's going to be between 0 and 12, 0 to 12, and zoom 0. We'll eventually need a graph of this. But for this problem, we don't actually need the graph. I mean, you could find the area under the graph using the graph, because you could do, I'll just do that. It's going to be second trace, and I hit 7. It's going to be the integral between 0, enter, 12, enter, and it will find that for me. And then that'll be the numerator, and I'll still need to divide by 12. So this number is divided by 12. This number is, oh my lord. Okay, so this is going to be equal to approximately 52056.8, oh, 0.808. That's all going to be divided by 12, which again is approximately that thing divided by 12, and 4,338.067. Oh, and it says round to the answer to the nearest whole number, so just undo that. It's 4,338. And that is our negative rate. And you can think of this as a negative or a positive. I guess our negative rate here, oh, if this is a rate, we have to be careful. Our negative rate is with a t. This many per hour, assuming that it's a constant rate. Oh, it does say a constant rate. It is a constant rate, so it's constantly pumping out 4,338 gallons per hour. Maybe you can either have this as a function. Here, I'll write it 2 ways. So our function, okay, K is equal to negative 4,338 gallons per hour, or you can have it as a function where it's times t. So I think this is the answer that they're looking for. All right, part B. To the nearest gallon, how much water is in the reservoir at 7 p.m.? Okay, so now we have to take that positive function, and we have to subtract our negative function to find how much is in at 7. Or so at time equals 10. So to do that, we need to do the integral between 0 and 10 of our positive rate, so our RT, and we need to subtract 4,338. 4,338. And all of that dt. And remember, this can be separated into 2 different integrals. You can kind of distribute the integral. So this is really going to be, we'll just write this really quickly, 0 to 10 of RT dt, and then minus the integral between 0 and 10 of 4,338 dt. Okay, what is this going to turn into? So let's punch this in on our calculator, 0 to 10. So I have math 9, var is right, enter, enter, comma x, comma 0, comma 10. Okay, so we have that integral, and then we're going to subtract this one. So I'll write this out so that you can follow my work too. It's going to be 49,504, 504.802, and I'm going to subtract. So this number is going to be 10 minus 0 times this. So it's going to be this thing with an extra 0. 4,338 0 because I just multiplied by 10. 10 minus 0 is 10. This is the integral of a constant function. So now I need to subtract 43,380 to get my answer, which is 6,124.802. And that's up to the nearest gallon, so scratch that, round that to 5 gallons. So this many gallons at 7 p.m. And almost done. We're on part C now. So at what time does the reservoir hold the greatest amount of water? Okay. So again, our volume function now is going to be, maybe we should just make a table. This one can't be solved with a table, I can tell. So we need to do 0 to 12, and there should be a critical value somewhere in here. So again, how do we find the critical value? Set it equal to 0, exactly. So this is actually the value that we're looking for. So let's plug this function into our calculator. So on our calculator, let's do y equals. So it's going to be that same thing minus 4,338. So I'm going to do bars, right, enter, y1 minus 4,338. And then I don't want to graph my first function. Let's turn that one off. And my window is still correct, so zoom 0. And now it's graphing this function to find where it hits 0. So these critical values we need to find, or these zeros we need to find.
From 0 to 12, right?
From 0 to 12, yeah, for the window.
Okay. You can take this before you go today.
All right, so we need to find those zeros. Now, it doesn't make sense to actually find that 0 because we're finding the greatest amount. And look, we have a negative area right here, so it would not make very much sense to plug in this value. We really should plug in this value because we have this positive amount of water. So it'll either be at 0, it'll be here, or at the very end. Probably not the very end because they have a giant negative value. So if you're being really, really smart, you could just do between 0 and that value. And just by looking at the graph, I'm pretty sure it's going to be that value. There's a giant positive area and then suddenly right here. So I'm not going to do 12. I'm just going to do 0 and that value. So to find that value, I do second calc 0, so hit 2, and I want to go, sure, left boundary good there. Let's do, I don't know, 10 and something in between there, 9. And we find the 0 is 6.798. 6.798. So those are our times, and then now we need to calculate the amount of water. So again, this is going to be start plus change, and that will equal the end. All right, the start, they say in the problem, is 500,000. So 500, 1, 2, 3,000, 500, 1, 2, 3,000. And this is going to be the integral between 0 and 0 of, it doesn't really matter because it's integral from 0 to 0. We know that this is 500, 1, 2, 3, 500,000. This one is going to be the interesting one. It's going to be between 0 and this time, which is 6.798 of our volume function. Our volume function is RT minus 4,338. So we'll just say RT minus 4,338, all that dt. All right, so we actually have that function already. It's this graph. This is the graph of RT minus 4,338. So on this graph, I need to find the integral between 0 and this value. So I'm going to do second trace, and I'm going to do the integral, 7. And it's going to be between 0 and 6.798. Hit enter. And it's going to shade in both these regions. It'll subtract this negative from this positive, and we get this number, and we need to add that to our initial condition. So I need to do second quick. We're adding that to 500, 1, 2, 3,000. So at that value, it holds 5,000, 1, 1, 3, 3, 8, around to the nearest gallon-ish. It doesn't actually ask for how much, it just asks for the time. So we can just be approximate here. So this is 511,000, this is 500,000. So obviously that one is the greatest.
What about 12? Do we do 12?
At time equals 12, the reason that I didn't do that is because on our graph, I knew that there's this giant negative value, so it's only going to go down from here.
Oh, okay.
Because that value down here, this area is negative. that's the reason that we didn't do 12. And now we need to write our final answer, so I might as well just hide that. Go away. Command H. Okay. So, and it's just asking for time. So at t equals 6.798 hours. Oh yeah, what time t? Because I was about to say, well, that's not the time, because the time actually started at 9 a.m. So I was like, okay, you have to add +3. So this is actually at 3 p.m. or closer to 4 p.m. because 0.79, but it just asks for the time t. So we're saying t equals this. At t equals 6.798 hours, the reservoir holds the greatest amount of water. The reservoir holds, oh my gosh, holds the greatest amount of water. And we're done. There's no scoring guide for this last one because it's not an actual AP question.